Alright, yesterday we started with this and we did a couple of problems at the very end of class. So what I'm going to do is I'm going to help you guys look at numbers 5 and 7. Alright, so right now what I'm going to do, we're going to look at problem number 5. I'm going to do the work for problem number 5 right here, and I'm going to do the work for problem number 7 right here. Now, on number 5 it says the ratio of the measures of the sides of a triangle is a 7 to 9 to 12 ratio. So what I'm going to do first is I'm going to build a triangle, right, to the best of my ability that represents kind of the lengths of the sides. May not be perfect, but there we go. So I'm going to call this a 7, I'm going to call this a 9, I'm going to call that a 12. Now, if I say, what is the perimeter of this triangle, 7 plus 9 plus 12, that gives me a total of 28 units, okay? So it's not that big, all right? But what is our perimeter if you look at it? It says our perimeter is not 28 units, it's what? 84 units. Now let's think about this. What if we have a perimeter that's 84, not units, but 84 inches, okay? Well, let's compare these right here. What I want you to do is I want you to put an X, and an X, and an X. Because what we're going to do is we're going to scale up. We're going to scale up this triangle so that it has a perimeter not of 28. Let's pretend this is 28 inches. We're going to go up from 28 inches, and we're going to go all the way up to 84 inches. So let's set this together. We got 7x plus 9x plus 12x equals a total of, we want it to equal 84. Right? We're going to make it equal to 84. So we add all these up. We have 16 plus 12x, that's 28x, equals 84. And then we're going to divide both sides by 28. 3.5? Okay. 3.5, is that what you got?
Yes, sir.
All right, check. We go. 84 divided by 28 is, I got 3.
Oh,
Interesting.
let me see what I did.
So what I'm going to do is I'm going to erase that. And I'm going to put a 3. Because 3 times 28 is?
I did 24 and not.
That'll do it. That'll do it. All right. So what we're going to do is we're going to take this 3, everybody. We're going to take this 3. And we're going to plug it in right here, and right here, and right here. And that will give us our actual dimensions for our triangle.
21, 27, and 36.
7 times 3, 21 inches. 9 times 3 is going to make that 27 inches. And 12 times 3 is going to make that 36 inches. Now, how could you check your
21, 27, 36.
They all have to add up to what? They all have to add up to 84.
Okay, how did you get 84 again?
Well, that was the problem. They said, all right, if you have a ratio of the measures of the sides that are a 7 to a 9 to a 12, its perimeter is what?
Oh,
84.
okay. Okay. That's how you got the. Yeah.
You would have gotten the answer right if you added 3. All right. So right now, let's look at problem number 7. Now 7 says not the ratios of the measures of the sides, but the angles. Okay, so now let's think about this. Let's draw a triangle where we have some angles that are bigger than others. Okay. So right now, I would say this is my smallest angle, so I'm going to call this 5x. All right, this is my second smallest angle, so I'm going to call that 7x, and I'm going to put 8x right here. Now, the ratios, these are the ratios of all the angles, but these ratios, a 5 to 7 to an 8 ratio, what do all the measures of the angles of the sum of all the angles in a triangle always add up to?
1/8.
1/8. So we know the measures of all the angles added together is going to equal 1/8. So we're going to set up 5x plus 7x plus 8x, but this time we're going to set it equal to 180 degrees. So we add 5 and 7 together to get 12, and then 8 together to get 20.
X.
20x equals 180. Then you divide both sides by 20, and x equals 9. Okay? But we're not done yet. Now we're done if it said solve for x, but it didn't say solve for x, it said solve for 3 missing angles, or find the measures of the angles. So we got to take that 9 and plug it in here, right there, right there.
You get 45, 63, and 72.
Now, if you would have written 45, 63, and 72, and I was really, really, really mean, I would mark it wrong. Because technically it's 45 degrees, 63 degrees, and 72 degrees. Always make sure you label your numbers with either inches, feet, if it's dealing with distance, if it's dealing with the measure of an angle. Make sure you write the degree symbol, because that's important. You're giving your answer what's called meaning. Numbers are meaningless without there being labels. A 45, a 63, and a 72 could mean anything unless you actually specifically say degree, degree, degree. And what should all of those add up to? 180. And that's how you check your answer to make sure.
So what did you do with the 9 in this one?
The 9? Oh, this right here. I took the 9 and I plugged it in right there. And so 8 times 9 is 72. And then 5 times 9 is 45. And then 7 times 9 is 68. So that's what I'm doing with. Once you solve for x, you have to take that answer and plug it back in. All right, today we're going to be talking about similar polygons. So I'm going to write similar polygons. All right, there's 2 things you need to know. Well, the first 2 things you need to know about all similar polygons is, all right, all the corresponding, or each corresponding angle is congruent. Okay? So right here, what I'm going to write now is all corresponding angles are congruent. All corresponding angles are congruent. So I'm going to highlight some corresponding angles right now. Start right here. So angle A, right here, angle A is going to correspond to angle E. Angle D, right here, I say angle D, that's going to correspond to angle H. Angle C corresponds to angle G. And last but not least, angle B corresponds to angle F. So corresponding angles are angles that are exactly equal to each other. So you'll notice A and E are equal, D and H are equal, okay? And so on and so forth. So that's step 1. All corresponding angles are congruent. So I highlighted those. Number 2, I want you guys to understand that the sides aren't equal, but the sides are proportional. So right here for number 2, what I'd like you to write is I'd like to write corresponding. Corresponding sides are proportional. Okay? And we'll talk about what those sides are when we write our similarity statement. We'll talk about what those are. I'm going to look over your shoulder here. It says, each pair of polygons is similar. Write a similarity statement. That's the first thing we're going to do. We're going to write a similarity statement. So in your journal right now, I want you guys to write similarity statement. Yeah, in your journal. Similarity statement. So right now, we're going to look at this, and I'm going to go in a particular order. I'm going to say trapezoid, or I guess technically we don't know that they look parallel, so let's call that trapezoid. All right, A, B, C, D. So basically this quadrilateral, A, B, C, D, is going to be similar. So we have a little similar statement. We have to go in the same order. So if I go A, B, C, D, I have to go E, F, G, H. So it's similar to E, F, G, and H. So this is right here. This is the very first part of your question. It says write a similarity statement. So right now, after you write that in your journal, now take that and transfer it over to your paper right now. That's the similarity statement that you need to have for problem number 8. Now in your journal, what I'd like you to do is I would like you to make some connections here. So right now, angle A I colored in blue, right? So check this out. What I want you to understand is, in a similarity statement, that A should match what angle? Angle A should match angle E. Alright, so that's what I'm going to do. Now, I'm going to look at B, changing colors. B should line up with what?
Angle F.
There we go, angle F, right here. You'll notice how I'm kind of making those connections right there. Angles, I'm changing colors now. Angle C should line up perfectly with,
Angle C.
yeah, very good. And last but not least, angle D should what?
Line up with angle F.
There we go. If you did your similarity statement correctly, each one of these angles, if you look, blue goes with blue, purple goes with purple, green goes with green, and red goes with red. That lets you know if you did it correctly. Alright? Now, the next thing I want you guys to understand is I want you guys to write over here, we're going to list all of the proportional sides. So right here, I'm going to write proportional sides. So we're going to list all the sides that are proportional. Now this is very, very, very easy. We're just going to go in the alphabet. Check this out. If I say the distance from A to B, A and B are right next to each other, right? Segment AB is similar, this one little squiggly line, that means similar, to E and F. Now I'm not even looking at the picture, but I'm going to check it right now. Let's look at A and B. Where is AB? AB is where? Right here. Where is EF? Right there. So they are. You can see that these are what? These are corresponding sides. So these are your corresponding, I'll put it in parentheses, proportional sides. These are the ones that are what? Corresponding. Okay. So now I'm going to work my way around. So I went from what? A to B. Now I'm going to jump from,
B to C.
no. It's going to go in order.
Oh, B to C.
Yeah. It's going to go in order.
F, F, G.
BC is going to be similar to FG. Without even looking at the pictures, if I wrote my similarity statement correctly, without even looking at the actual quadrilateral, I know which sides are proportional or similar to each other. Now I'm going to jump to what? CN,
CD.
CD,
G, H.
GH. Now the last one, I'm going to start. The first to the last is the same as this first to the last. So what's this one?
AD.
AD.
E, H.
There you go. So all of these sides, they're not equal, but all of these sides are proportional. All right, they're proportional. So now what we have to do is we're going to be looking at what's called a scale factor. Okay, we're looking at a scale factor. So let's look carefully at our picture here. All right, let's talk about what a scale factor is. A scale factor, you have two things. It's either going to be what's called an enlargement or it's going to be called a reduction. Okay? So I'm going to call X what's called a scale factor. I don't know what X is always going to be. I know what it is for this particular problem, but I don't know what it's always going to be. But in an enlargement, your scale factor, I'm just going to call it X, will always have to be greater than the number 1. If you want to make something bigger, multiply it by a number that's greater than 1, and it will make something bigger. If I said I'm going to multiply your height by 2, then you'd be a giant. Okay? Because I'm scaling you everything up by what? Everything up by 2. Okay, that's called an enlargement. If your scale factor is what? Greater than, this is the symbol for greater than. Greater than 1. Now, a reduction, your scale factor is going to be what's called less than 1, but it's still going to be greater than the number called 0. Because if you multiply anything by 0, it just makes everything equal to 0. So what would be a reduction? A reduction is going to be what's called a fraction. All right? Not an improper fraction, just a regular fraction. So what would be a reduction? Like a half, right? Or if you multiply something by 2/3, it's going to shrink. That's what a reduction is. So you're either going to have an enlargement or you're going to have a reduction. Okay? So right now, let's look at our situation here. All right? Right now, we have a 14, and this is a 7. Here we have a 12, this is a 6. Here we have a 26, that's a 13. So it depends on what you... It's half of that, right? So if we're going from, watch this, here's what I want you guys to understand. If we're going from A, B, C, D, and you're going to E, F, G, H, that's considered a reduction. So our scale factor for this problem, if you're going from the bigger, right? If you're going from big to small, that would be a reduction, and what would your scale factor be? It would be a half. But if you're going from small to big, what is small to big? That's saying, well, what if I said you started with E, F, G, H, and you were going to A, B, C, D, then that's not going to be a reduction. That's going to be an enlargement. And our enlargement would be a scale factor of 2. So if you're going from big to small, it's going to be a half. If you're going from small to big, it's going to be 2. So right now, on your paper, it says, solve for x, and it says, find the what? Find the scale factor. All right? So find the scale factor. So right now, we have 2 scale factors in play. If it's a reduction, it's a half. If it's an enlargement, it's 2. So right now, I'm going to go just look at our page right here. And right now, I want you to compare. This side right here, we're comparing this side to this side. All right? So all we're going to do is we're going to compare 13 to x. We're comparing 13 to x. Now, I don't care which other side that you use. If you wanted to use AD and compare it to which side? EH. Well then, right now, 13 is on my base. Right now, I'm comparing big to small. So I'm doing 13 to 14 equals x over 7. So 13 to 14 equals x over 7. I'm kind of color coordinated. This is how you set up your proportion. You have to set up your portion correctly. Notice, blue to blue, purple to purple. Big to small, big to small. So order matters when you're setting up a proportion. You could set this proportion up incorrectly, like if you got, for some reason, you got those inverted. Okay? So now when we cross multiply, what do we get? We get 14 times x equals 7 times 3, which is
7 times 3.
Sorry, 7 times 13, which is 91. And then we divide both sides by what?
14. 6.5.
Okay. So we have x equals 6.5. And when it says solve for x, that's what it asks you to do. It asks you to solve for x. So let me explain to you what you're going to have on your assignment. I'm going to give you the 3 answers that you need for this problem so you know what I'm asking you to do. Okay. Here's the work. I'm going to go over here just to the left in case you're writing that down. Number 1, it said write a similarity statement. And our similarity statement was this. A, B, C, D is similar to E, F, GH. All right. Next thing it says solve for x. We'll put x ended up being 6.5. 3. It asked us for the scale factor. And technically, depending on which way it goes, all right. If we have an enlargement, what was the scale factor for an enlargement? 2. So the enlargement was 2. Right here, what was the scale factor for the reduction? 1/2. So what I want you guys to understand, I want both factors. Tell me, if you're talking about it being enlarged, it was this. If you're talking about it being reduced, it was this. So this right here is your final answer for number 8. What's your final answer? What I'd like you guys to do is attempt to do 9, 10, or 11 on your own. Just set them up and we'll check them here shortly. One thing I forgot right here is the 4th one where it says actually find the measure of the indicated side. So right here it says find the measure of GH. Well, GH in this particular case happened to be X. So GH, also put GH equals 6.5. We're going to move over here to problem number 9. So we are looking for ST and SU. So the very first thing we're going to do is we're going to write what's called the similarity statement. Okay? So, number 1, I'm going to write a similarity statement. So I'm going to write triangle. Okay? Triangle, I'm going to start with angle W, then go to X, then go to Y. So I'm going from W to X to Y. And that's going to be similar to triangle. What is W going to be similar to? W, S, to T, to U. So that's my similarity. Okay. So I'm going to highlight things that are going to be, these angles right here are going to be definitely congruent to each other. So fortunately, why am I coloring in both of these angles blue and not different colors? Because these sides are the same, which means these angles, these are isosceles triangles, okay? And in isosceles triangles, base angles are equal, and what? These legs are also equal. So right now, check this out. This side right here is a what? 3. This side is a 9. So we're going to set this up. Let's go right over here. We're going to go ahead and solve this. We're going to compare the 3. We're comparing that number 3 to 9. We're going to compare it to a 9. Okay. And then I'm going to take the other side, which is a 4, and I'm going to compare that to what side? The x plus 5. Now, which sides am I comparing? I'm comparing what? xy right here to what? tu. And then I'm comparing wy to s and u. So these right here, then you set them equal to each other. Just like this. Now, what have we set up? We've set up a proportion. So once you set up a proportion, what are you allowed to do? That's right. You're allowed to take these cross products. So we're going to take this 3 right here, and we're going to multiply it to the sum of x and 5. Notice I put that in parentheses. Very important that whenever you have a binomial, you put it in parentheses. And then 4 times 9, I'm going to write, instead of writing 36, I'm going to write 4 times 9. So you can see that, what am I writing right now? I'm writing the cross products. Now, 4 times 9 is 36. Distribute 3. 3 times x is 3x, 3 times 5 is 15. Then we will take away 15 from both sides. So we have 3x equals 21. We're not done. That's one of the things we need to find. Okay, so right here, which is x equals 7, right over here, I'm going to write Okay, one of the things we had to find was x, right? X equals 7. But now, what we need to do is we need to take the 7 and plug it in here, and take the 7 and plug it in right there. And what's that going to give us? That's going to give us the measurement, I'm going to scroll down a little bit, of STN SU. So right now I'm going to write ST equals 12. SU equals 12. And the last thing I have to find is my what? My scale factor. So right now, I'm going to let you guys write E for enlargement and R for reduction. E for enlargement, R for reduction. If you write those on your paper, I will know what you're talking about. Okay? Now, if it's an enlargement, okay, we went from a 3, what, to a 9. So what would be the scale factor for the enlargement? 3, because 3 times 3 is 9. So right here for the enlargement, you're going to write it was a scale factor of 3. But if I have to multiply a fraction by a 9, what fraction would I have to multiply 9 by to get to a 3? A third. Right. How'd you do that? So here's what I did. 9 divided by 3 is my what? Scale factor of 3. But if I say, what's 3 divided by 9, that reduces it to a third. The number that's bigger than 1 will be your enlargement. The number that's a fraction is going to be your reduction. And this is your final answer, right here. That right there is your final answer for number 9. You have 2 homework problems.